You ever stop and think about what it really takes to make your favorite t-shirt? I mean, it's way more than just some cotton and thread, right? Today, we're going to dive deep into the invisible science that turns those raw materials into the super soft, perfectly colored clothes you have hanging in your closet. So, what is the secret ingredient here? Is it some kind of fancy dye? A top secret weaving technique? Think about that perfectly crisp white shirt, or maybe a really vibrant red hoodie. What gets it to look that way? Well, I can pretty much guarantee the answer is not what you think. Believe it or not, the single most important and, yeah, the most complicated ingredient is just plain old water. I know, right? But as you're about to see, in the world of high-tech textiles, water is anything but plain and simple. It's kind of like a main character in this story, and it has a lot of different sides to it. So to get that perfect fabric, manufacturers have to start with the water itself. And it turns out, where that water comes from, well, it changes everything. It dramatically affects what you can do with it. So let's take a look at the four main sources they're dealing with.
All right, here are the big four. You've got rainwater, which you'd think is the purest, right? Then there's surface water, from rivers and lakes. After that, subsoil water from shallow wells. And finally, deep well water from way down deep. And here's the kicker. Every single one has its own unique chemical fingerprint.
And this is where it gets super interesting. You totally think rainwater would be the best, the purest, but nope. As it falls, it actually picks up pollutants from the atmosphere. And then you have surface water, which is like a rolling snowball. As it moves across the land, it just keeps collecting more and more mineral salts. And those salts are a huge problem for the dyeing process. The story doesn't stop there. It goes underground. Subsoil water, for instance, gets filtered by the earth, which sounds great, but it also absorbs a ton of dissolved CO2. And deep well water? It might be free of all that organic gunk, which is a plus, but it often contains the two elements that are basically the ultimate villain in our story, calcium and magnesium. And that right there brings us to the core problem, the main antagonist for pretty much every textile manufacturer out there. It's called water hardness. And this one single issue, man, it can literally make or break the entire production process.
Okay, so what is water hardness, really? Well, to put it simply, it's all about those dissolved calcium and magnesium salts we just mentioned. And to get specific, we're talking about bicarbonates, sulfates, and chlorides. These are the little culprits that sneak into the water and just cause all the trouble.
You've probably experienced this yourself, and you might not have even known it. Ever washed your hands and the soap just won't lather? It leaves that kind of sticky film behind? Yep, that's you meeting hard water face to face. And those exact same minerals that stop the soap from working are the very ones that wreak absolute havoc on dyes and fabrics. And this isn't just some vague concept, it's a measurable science. Hardness is graded on a really precise scale. For textile processing, the goal is crystal clear. The water has to be very, very soft. Anything else, it's basically a recipe for disaster. Oh, and to make things even more fun, there are two types of hardness. First, you have temporary hardness. This comes from bicarbonates, and it's actually the easy one to fix. You can literally just boil it away. But then there's permanent hardness. This one's from chlorides and sulfates, and wow, this stuff is stubborn. It could not care less about boiling. It needs a way more advanced solution. So why is this such a huge deal? Well, because the second hard water gets into a textile factory, it kicks off this massive chain reaction of problems. And we're not just talking about a slightly off color here. We're talking about millions of dollars in wasted materials, wasted energy, and clothes that are totally ruined before they're even finished. And the damage it does is just so widespread. We're talking about at least 7 critical stages in making a t-shirt. I mean, from the very beginning, preparing the raw fabric, all the way to the final finishing touches, hard water messes with every single one. And the specific problems are just staggering, really. In the dyeing stage, it can completely mess with the color, turning a beautiful bold red into some kind of washed-out pink. During bleaching, it can actually cause the chemicals to decompose. Even in the first cleaning step, it makes the fabric turn yellow. For quality control, it is a complete and utter disaster. But hey, where there's a villain, there has to be a hero, right? And in this story, our hero is industrial chemistry.
Engineers have come up with some truly incredible ways to fight back against water hardness, to purify that water before it gets a chance to do any damage. The solution has a simple name: water softening. And the goal is just as simple and direct. You gotta get those dissolved calcium and magnesium salts out of the water, period, before they can cause any trouble. Now, there are a few ways to do this, but we're gonna focus on the three main industrial workhorses. You've got the classic soda-lime process, the much more efficient base exchange process, and then the ultimate purification method, which is called demineralization. Okay, first up is the lime soda process. So what happens here is the raw, hard water gets pumped into these big reaction tanks. Then they mix in lime and soda ash. These chemicals kick off a reaction with the calcium and magnesium, and it basically forces them to turn solid and precipitate, which is just a fancy way of saying they fall out of the water. After that, they can be filtered away pretty easily. Next, we have a much more elegant solution: the base exchange process. Here's how this one works. The hard water flows through a bed of this special material called zeolite. Now, the easiest way to think of zeolite is like a mineral magnet. It just grabs onto those hard calcium and magnesium ions, and in exchange, it releases harmless little sodium ions back into the water. It's clean, it's simple, and it's incredibly effective. And the advantages to this method are huge. First off, it gets the water down to almost zero hardness. The equipment itself takes up way less space, which is a big plus. And maybe best of all, there's no gross, messy sludge to clean up and get rid of. All that makes it a way more efficient choice for a lot of modern factories. But if you need the absolute highest level of purity, well, that's where the demineralization plant comes in. This is the top tier, the big guns. It's this powerful two-stage process. First, it uses one kind of resin to pull out all the positive ions, like our old friends calcium and magnesium. Then a second resin removes all the negative ions. What you're left with is water that isn't just soft, it's almost entirely free of any dissolved minerals. We're talking incredibly close to pure H2O. So after all that complex chemistry and all that amazing engineering, we can finally bring this whole story full circle, right back to the clothes hanging in your closet. So the next time you pull on your favorite t-shirt, just remember this: that perfect, soft feel, that vibrant color that doesn't seem to fade, that is no accident. It is the direct result of a scientific battle that was won long before that fabric ever touched a single drop of dye. It's the victory of soft water over hard water.
And it really makes you wonder, doesn't it? If there's this much complex science hiding inside something we think of as simple as a t-shirt, what other incredible invisible science is shaping all the everyday objects that are all around us?